Alright, so I've tried to download many different things to try to make a video just to show you some things, but this is the best option I have right now. I wanted to go today over 12.8 and 12.9, where we talk about quadratic linear systems, as well as quadratic systems, which are even more difficult. But to start with, we can think about just some quadratic linear system. For example, we have parabola and a line. And we have several options for this. The first is that we have a parabola up here and a line over there. So we would call that an inconsistent system. Inconsistent, because there are no solutions for it. Another option is we have a parabola that touches our line in a single point. So then we have one solution. And the third and the last option is we have a parabola that touches in more than one point. Two solutions. So for any quadratic linear system, you're either going to have 0, 1, or 2 solutions. Now let's do an example of a parabola and a line to see what happens. We have an equation. Let's say y equals 3x squared plus 5x minus 2. And we have a line. Y equals 2x minus 8. Okay, so to start out with, we would want to get a visual on what that would look like. We know that our parabola has a y-intercept of -2. It looks like 5x in the beginning, and then it looks like 3x squared. So we have something like this. And our y is going to go down to -8 as the starting value, and it's going to have a smaller slope. Its slope is only 2, so it's going to actually look something like this. So when we do this, we would expect to get 0 solutions for this system. So let's actually do the algebra out, and so that you can see what that would look like. So I'm going to move this system of equations down here so that you can see it a little bit better, and we can track y equals 3x squared plus 5x minus 2, y equals 2x minus 8. Well, this one's pretty simple because we have both of these equations set up in y equals to begin with, and if y equals this, y equals that, that means those two things have to equal each other. That's the transitive property. If a equals b, b equals c, then a equals c. So what I'm going to do is I'm just going to come down here and set those two equations equal to each other. And now I'm hoping, since I have a quadratic, I'm probably going to think of the quadratic formula when I do this. But let's just move everything to the other side. So plus 8 and minus 2 from both sides. That gives us 0 equals 3x squared plus 3x plus 6. Okay, so I'm going to go ahead and use the quadratic formula for this. Apps, polysmelt, polyroot finder, and a is equal to 3, b is equal to 3, c is equal to 6. I'm going to solve that. It gives me non-real solutions. Let me just check that on paper then. X equals -b plus or minus square root b squared minus 4ac all over 2a. Okay. And that would give us non-real answers, as you can see, because we have the discriminant. 9 minus 4 times 3 times 6 is going to be a negative number, so then we would get that x is non-real, which means there are no solutions to this equation. And so if there's no possible x value, we obviously can't get a y value out of it. So that's how we would solve a quadratic linear equation. You'll see other examples. Hopefully you can see this pretty well. I'm going to come over here and I will stick in a system of equations. X times y equals 6 and 2x plus y equals 8. Well, when we look at that, we need to think first, what type of equations am I even graphing? If we think about this first one, x times y equals 6. If we solve for y, then we get y equals 6 over x. And when you graph that, that's an inverse variation, as we talked about back in chapter 2. We get something that looks like this, which you should think to yourself, hey, that's a hyperbola. And we have a line. And we can also solve that for y. Y equals negative 2 plus 8, negative 2x plus 8. So then we have 8, negative 2. Something like this. So it should intersect in 2 points, just based on that drawing. So again, let's go ahead and try to solve this, the system of equations. We have 2 different variables. So the first thing I'm going to do is solve for either x or y in one of those, and then I'm going to use substitution to put it into the other equation. A simple one I have here, x times y equals 6, so I can just solve for x. X equals 6 over y, or we already had y, but anyway, so now I have x, I can plug that into my second equation. 2 times 6 over y plus y equals 8. Now I want to solve for y. So I have 12 over y plus y equals 8. 12 over y plus y. Wow. Algebra. I'm actually going to multiply everything by y to get rid of that fraction there. So 12 plus y squared equals 8y. Whew. And now we can, again, we probably don't need to use the quadratic formula, but let's get everything on one side. Y squared minus 8y plus 12, I'm thinking, is equal to 0. Can I factor that? Is there something times something that equals 12, and such that when you add them together you get 8? And there is y minus 6 times y minus 2 is equal to 0, which means we have y equals 6, y equals 2. And then I'm going to plug that back in to my equations. All right, so to solve for x, x times 6 equals 6. Well, that's easy. X equals 1. X times 2 equals 6. Well, then x equals 3. Equals 3, not x times 3. And those should be our 2 solutions. We have 1 and 6, as well as 3, 2. Those should be the 2 points where we get an intersection on the graph. We can check that. You can check it by graphing, or you could check it by plugging those 2 points back into your equations. Either way, those are going to work. Okay, I'm going to pause the video there, and then I'll come back with quadratic to quadratic relationships.